The Klang Valley Mass Rapid Transit, or KVMRT, is a 51-kilometer rail-based public transport that will be the backbone of a new sustainable transport system. Due to their proven track record in tunneling underground, MMC Gamuda KVMRT Tunneling Sendirian Berhad was awarded the largest work package by the government to design and construct the 9.5-kilometer underground works for the KVMRT Sungai Buloh Kajang line. The underground tunnel goes from the North Portal in Semantan to the South Portal at Maluri. The tunnel connects 7 underground stations: KL Central, Pasar Seni, Merdeka, Bukit Bintang, Pasar Rakyat, Cochrane and Maluri. 10 tunnel boring machines, or TBMs, are commissioned for the project. Tunnel boring machines excavate rocks and soil with special tools fixed on a rotating cutter head, while building permanent walls at the same time. In March 2012, MMC Gamuda KVMRT sealed the agreement to purchase 8 TBMs from Germany's renowned tunneling equipment specialist Herrenknecht AG and 2 TBMs from China Railway Tunnel Engineering Corporation. Of the 10 machines, 4 earth pressure balanced TBMs will be used to tunnel in the Kenny Hill Formation soil condition, while 6 variable density TBMs will be used to tunnel in the difficult karstic Kuala Lumpur limestone formation. The variable density TBM is the first of its kind in the world and is a result of combined initiatives from Malaysia's tunneling experts from MMC Gamuda and Herrenknecht AG. The factory acceptance test for the first TBM was held at Herrenknecht's factory in Schwanau, Germany in November 2012. The first TBM has been tasked to mine from the Cochrane site. The Cochrane Station site has the largest construction footprint, which measures about 14 acres. Work started on the site in May 2012. Secant board piling was used to build the retaining walls. Once completed, control rock blasting was employed to excavate the shaft down to a depth of 30 meters.
Blasting itself is a very dangerous activity, so definitely there's no room for even the slightest mistake. Therefore, the safety measures need to be followed strictly throughout the whole process. And second is to control the vibration and the sound to the allowable limit so that it will not induce any damage to the surrounding buildings.
Excavation of the shaft took approximately 9 months to complete. With the completion of the shaft at Cochrane, the first variable density TBM arrived on site in early February 2013. Parts of the machine were lifted and lowered into the shaft piece by piece and carefully assembled at the launching platform. The launch of the first variable density TBM was officiated by the Prime Minister of Malaysia, Datuk Seri Najib Tun Razak, on 30th May 2013. The second variable density TBM was also assembled and began mining in July 2013. Both the first and second TBMs are mining towards Pasar Rakyat. As the TBM mines, tunnel rings are built behind the machine to form the tunnel walls. 2 more variable density TBMs were assembled and launched in October and November 2013 respectively and are mining towards Maluri. Building of the station began with the construction of the base slab and walls. This was followed by the construction of the platform, columns and the mezzanine level. The Semantan North Portal, located at the intersection of Jalan Duta and Jalan Semantan, is the launchpad for 2 parallel earth pressure balanced TBMs. The portal and its ancillary structures, as well as the logistics area to support mining activities, were completed by early 2013. The TBMs from China arrived on site in February 2013, and each TBM took approximately 6 weeks to assemble. The first earth pressure balanced TBM was launched from the Semantan portal in June 2013, and the second TBM began mining 1 month later. As the TBMs mine and build walls, excavated material is transported out of the tunnel and stored temporarily in a muck pit before it is removed from the site. The earth pressure balanced TBMs are mining through the more stable Kenny Hill Formation towards KL Central. The Samantan portal will continue to service the two earth pressure balanced TBMs until they complete their drives at Pasar Seni station later in 2014. From the Inai launch shaft, a variable density TBM will be launched. The shaft was constructed using secant board piling. It was excavated to a depth of 34 meters. Chambers were dug for the assembly of the TBM. The TBM arrived on site in October 2013 and took 6 weeks to assemble. The task was extremely challenging due to the space constraints.
The major challenges in this shaft is, if you can see yourself, it's a smaller shaft. So the TBM is 140 meters long, but down there it's 50 meters. So we can only assemble at just a third of the TBM.
The TBM began mining in December 2013, and as it mines forward, remaining parts of the TBM are lowered into the shaft and attached to the mining machine. The TBM is mining towards the Bukit Bintang station. The Bukit Bintang station is at the junction of Jalan Bukit Bintang and Jalan Sultan Ismail. Building the underground station here is a major challenge because it is located under the busy thoroughfare.
This station, located in the heart of the city, which we call the Golden Triangle of Kuala Lumpur, the location itself is already the biggest challenge. You look at the surrounding, they are highly built up, densely populated, and then you can imagine the utilities, the services we have to deal with is a tremendous challenge.
After full possession of the site, relocation of utilities was carried out. The construction of the station box is being done in stages. During the first stage, the road was realigned to allow the construction of one half of the station box. Diaphragm walls were constructed, king posts installed, and strutting was carried out. The struts support the diaphragm walls, which in turn hold up the soil at the sides. A top-down construction method is being carried out here. Soil is excavated to just below the roof slab. Then the roof slab was constructed. Once completed, struts were removed and geofoam blocks were used to fill the void. The site was backfilled and covered. A road was constructed above to allow realignment of the traffic and the second stage of the station box construction. Due to the Yayasan Selangor's basement, which protrudes out into the construction footprint, extra care was taken when the diaphragm walls of the station box were constructed. KL Central Station is also using the same top-down method of construction. The station is located in front of Museum Negara, underneath Jalan Damansara, and has a construction footprint of approximately 2.25 acres. Work on site started in April 2012. Due to its close proximity to Museum Negara, monitoring works are conducted daily on the building and the picture murals to ensure that this heritage structure is not affected by the construction activities. Diaphragm walls and ground anchoring of the station box took approximately 6 months to complete. The station box was excavated down to the roof slab level and king posts were installed. The roof slab was constructed with excess openings for work to proceed downwards. Excavation and construction of the station box then continued beneath the roof slab. The KL Central Station consists of 2 levels, namely the concourse and platform level. The concourse level was completed first. Construction of the platform level then proceeded below the concourse level. On 24th December 2013, the first earth pressure balanced TBM broke through the KL Central Station at the platform level.
Yes, great. Finally, I pushed my machine, came in. I've been working for more than 24 hours. I can have a good rest.
The second TBM broke through 3 weeks later. Both the TBMs are currently undergoing maintenance work and are expected to relaunch from the station at the end of March 2014 to continue the drive to Pasar Seni station. Pasar Rakyat Station is where the first variable density TBM will break through. This station is located at the junction of Jalan Tun Razak and Jalan Kampung Pandan. The station box is the largest and deepest and was constructed using secant board piling method. Control rock blasting and a surface miner is used for excavation of the station box. This site will be excavated to a depth of 45 meters and will churn out nearly 300,000 cubic meters of rock and earth, a volume that is equivalent to 120 Olympic-sized pools. Preparatory works were carried out for the arrival of the first variable density TBM. On the 9th of January 2014, the TBM broke through.
We have more than 200 of our homegrown Malaysian young lads working with us, running the machine. It's one of the proudest things for me in this project other than the physical achievements of the machine.
This is a great moment for us, and we have proven that we have done well, and I would say that we will continue for another few more machines to make sure that it's come out as well as it is.
The TBM has completed its drive and is being dismantled. Located in Cheras, the Maluri MRT station and the integral crossover box measures 9.14 acres. Due to its location at a busy dual carriageway, the station box construction is done in stages. Secant board piling is used to construct the perimeters of the station box. This station is also being constructed in a top-down manner. Once strutting is completed, temporary road decks were put into place to allow the traffic to be realigned and construction of the other parts of the station box can be completed. But under the road decks, work continues. Excavation works is carried out using controlled rock blasting. Extreme care and planning is required, and the road is temporarily diverted during the blasting. In the Maluri area, the TBM will pass under very sensitive structures. Efforts are being made by the risk mitigation team to ensure that the TBM's passage does not cause any danger to existing structures.
One of the complex area where I'm looking at the moment is called Sungai Kerayong. And in Sungai Kerayong, there are two major things that we need to do. First of all, we need to underpin the existing bridge, and secondly, we need to strengthen the ground condition before the TBM arrives. Whatever there's voids, there's gap, we fill up with ground, and at the same time, when we reach the soil portion where the soil is very weak, we need to strengthen the soil by using jack grouting, so that when the TBM moves through this grouted block, it will be quite safe and stable for the TBM to go through.
The Maluri South Portal acts as the transition between the elevated and underground section of the line. It also acts as a shaft for retrieving the variable density TBMs from Cochrane. Preparatory works began on-site, followed by secant board piling. Once the portal walls at the retrieval section were completed, excavation through controlled rock blasting is carried out until it reaches a depth of 15 meters. Where the underground interfaces with the elevated section, strutting works were carried out, followed by excavation works. Structural works are also ongoing. The Pudu launch shaft is another launching site for the earth pressure balance TBM to mine northwards towards the Merdeka station. This is also one of the escape shafts for this line. Preparatory works, including diaphragm wall construction, began in July 2012. The roof slab was constructed with 2 excess openings to allow work to proceed downwards. These will also be the points where the TBM parts will be lowered for assembly. Using the top-down construction method, 4 levels are being constructed under the roof slab. On the ground level, the logistics area to support mining such as muck pits and the gantry crane are already in position. Parts of the TBM began arriving on site in February 2014, and assembly is expected to begin 1 month later. The Merdeka Station construction area measures 1.85 acres. Preparatory works started in April 2012. Diaphragm wall construction for the station box was completed in early 2013. king posts were installed along the center of the station box to support the temporary strutting system that strengthens the walls against lateral earth pressure during excavation. 4,000 tons of steel was used to form 6 layers of struts that spans across the 32-meter deep station box. At the final excavation level, subsoil pipes are being installed to channel groundwater out before base slab construction works begin. Located at a popular tourist area, the Pasar Seni station footprint includes the structures of UO Superstore, Plaza Warisan and KLANG bus terminal. Demolition of the 3 buildings took 6 months to complete. Construction of the station box is done in stages, starting with the construction of the diaphragm walls at the KLANG bus terminal site. King posts were then piled and temporary struts were installed to support the completed diaphragm wall. Using a semi-top-down and bottom-up construction method, the concourse level is first constructed concurrently with demolition of the basements. With a concourse slab in place, construction of the roof slab then begins. On Jalan Tun HS Lee, road diversions had to be carried out in stages to include the area into the construction footprint. Here, a protection box is being constructed to protect the 132 kilovolt cables located beneath the road.
After we had discovered the existence of the cable in Jalan Tun HS Lee, we come out to the conclusion that this cable must be fully protected. We drove 2 rows of vertical sheet pile and we are jacking the horizontal sheet pile, so create as a steel box, and this steel box will be hoisted up to the permanent dual of the station. The whole box will be independent of our excavation, and then we can excavate below the box without endangering the 132 kV.
The Safety, Health and Environment Program is an important component of the project. Various initiatives are taken to ensure the safety of everyone involved in this project. The underground works for the KVMRT is progressing well and on schedule. All teams from MMC Gamuda KVMRT are working closely together to attain the highest standards and best engineering design.